Hey, it's Amateur Stat Hour again. I hope to get through some examples looking for critical values from section 7.2. Hopefully I won't make too many mistakes. I'm going to jump on over to my other screen and then we'll run through some examples on finding critical values. These are t-scores used for confidence intervals and hypothesis testing. All right, so section 7.2, finding t-scores, very much like z-scores, but with a t. We've talked a little bit about t-scores already. So, critical values, I will remind people. By the way, CV is a common abbreviation for me. For these critical values, these are values that will help us to identify significant outcomes. And hopefully distinguish those from outcomes that are not so significant. To do this, we'll use the t-distribution, and there's a couple of things that we'll need to supply. We'll need to supply area, and either left, right, or two tails, depending on the question at hand. And in addition to that, we need to supply the degree of freedom, which is equal to n minus 1. In terms of a picture, the t-distribution looks very similar to the z-distribution. It's centered right there at 0. We're going to be finding critical values that identify significantly large t-values and significantly small t-values. The area in each case is equal to this alpha over 2. Now, I'll remind people that the area is identified by looking at the level of confidence, and that level of confidence is equal to the 1 minus alpha. That alpha is the alpha that appears right there. Now, in terms of a process, we'll want to identify those critical values there. So, what do we need to do to identify these critical values? Most importantly for my students is to draw it first. I can't overemphasize that particular aspect. We're going to draw it first. Then I can go ahead and label and identify potential scores and where they might be. These two things are really important. That'll make sure I use my tools correctly and I'm getting the proper critical values. The program we use. The program we use is the T-inverse 83. This is one of those programs I installed on your calculator before we broke. Now, if you do not have your programs, I'll go over that in just a few moments. You'll still be able to do the problems just fine. Now, if we have the programs, I'm going to have to supply a couple of different things. Mostly what I said before, I'll need to supply a degree of freedom. That's the n minus 1. And the tail or tails and area. Once I do that, then I can go ahead and use my calculator to find the t-score. So it's going to do that just fine. So for my first example, we're going to find the t-scores for a 95% confidence interval. My sample size here is n equals 42. And I'm going to find the critical values. Now, as I say, we're going to want to draw a picture first. Alpha will be given somewhere in the problem, 5% or 0.05, whatever the case might be. It's somewhere there in the problem. So what I'm going to do is I'm going to draw now my distribution, then I'm going to reach for my calculator. So the distribution goes up and then down. Zero's right there in the middle. I'll have a critical value on the right, one on the left as well. Remember, the area I am after is this area right here. That is the 0.05. So each of those areas, I guess if you want to think of it that way, is 0.05 all over 2. Sometimes we need that expression, sometimes we don't. Here, we're going to be just fine with the 0.05. So I get my calculator. I've got my sample size. That also enables me to go ahead and identify my degrees of freedom, 42 minus 1. So let's see what my calculator will do for me. Under program, there's the T inverse 83. Works very similar to the inverse normal program. I'll select 2 equal tails. I'll enter a degree of freedom. 42 minus 1 is 41. You can actually make your calculator do the arithmetic for you. The total area of the 2 tails, that's my alpha, 0.05. That's what goes in. So I have 2 critical values. On the left, negative 2.02. On the right, 2.02 in the positive. So that takes care of finding critical values if I'm going to use my program. As I said, sometimes those programs disappear. So if I do not have access to my programs, I have no access to my programs, I will use the distribution tool. The distribution tool is the key that looks like DSTR. I'll need the second key first, and you'll see me run through the keystrokes here in just a moment. I am looking for the tool called inverse T. And this is actually the tool that the program itself uses. So that inverse T, we have to work with it in a very special way. It'll come with an open parenthesis. I'll supply some area and the degree of freedom. And it gives me back just a single score. Here's the deal with the area. It measures area strictly from the left only. Only and always. Because of that, we get just one score. And I'll show you how we deal with that. Now remember, the pictures and everything that we use are designed to help us get through the problem. This really isn't about graphing per se. So I'm going to use now my new distribution tool, and I'll show you where it is in just a moment. We are going to find the critical values for the 95% confidence interval. That 95% confidence interval will have a sample size of 42. Because I'm working with the 95% level of confidence, I already know my alpha is 0.05. So let's see. As I say, these pictures are designed to help us think, so I like a schematic sort of approach. Yes, in my brain, it's still a normal distribution, but it looks very angular today. So I have 2 critical values. one on the left and one on the right. That's what I'm after. These guys down here. I'll need my degree of freedom. My sample size was 42, so 42 minus 1. You'll notice that it's essentially the same problem we did before. Now, let me get my calculator. The distribution key is right there, right up above the vars key. So I'll hit second, followed by the vars key. And this shows me my distributions. My inverse T tool is right there. In it goes. And now I can input the area. In this case, I do need 0.05 divided by 2 for that little bit of real estate there. That's okay. My calculator can handle that. 0.05 divided by 2. The other thing that I'll need to make sure I use is the comma key. I'll put that in a moment right there. Remember, it's right up above the 7. And now I'll put in the area in question. Excuse me, the degrees of freedom is 41. There we go. Close them up. Thanks for a moment. And I'll notice that I get a negative 2.0195 and change. So how do we like to play this? If I take that to 3 significant digits, 3 decimal places, excuse me, I get the same value we had before, negative 2.02. Now, how do I get the positive value? Well, I'll remember that this is a symmetric distribution. So what happens on the left also happens on the right. So a positive 2.02. So there we go. We've used the 2 distinctly different approaches. We've used the inverse normal 83 program, and we've used the distribution tool, inverse T. They work a little bit different, but they give us the same results at the end of the day. So thank you for listening. I hope you found this helpful.